Okay, several announcements. One for those who have left their requests on voicemail, email. I have the numbers so far that have been requested, and whether we're going to have a chance to do everything, a little bit debatable, but we'll do our best to try to get through as many word problems as possible. But one of the things I did want to address here, this is a Monday now on our third week of classes. Tuesday, third week. It's my Monday, okay? Thank you. It is Tuesday. We had yesterday off, so it's an abbreviated week. But at any rate, those of you who are watching this on the video base, looking at the lectures as they are presented in the computer labs, I do appreciate what I have asked that you do, and that many of you have done it, and that is send me an email each week letting me know how things are going. I'd like to know how progress is going. And given that we have possibly somewhere around 40 or more people doing that, I'm hearing from about 10. So that means there's about 75% of the people who are watching who've not evidently picked up on that, and that first week of lectures, that you are asked to forward an email to me. So all you have to do if you're watching, and I'll share that with you this morning as I show you the web page, you just click on my name, it sets up a message to me, and then I can determine if indeed you're involved, because I'm going to be doing updates, and if I have not heard from you, then I'm going to assume you're not involved and don't really plan to be taking the course, and because of that you may be dropped. So again, the request, please take time to send me a message. This isn't for the students who are in class in the on-campus version, but for those of you who are watching the lectures on a daily basis. So what we're going to do, Debbie, is we're going to go to the document cam for a moment. This is my home page that's involved, and what I'm going to do, let's see if I can, by any chance, do anything that will, let me try doing an overscan. Let's do it that way. And I'm going to go ahead and go in the middle of this globe, and as I click there, what's going to pop up is the home page. And that's not doing what I wanted very well, so I guess I'm going to have to go out of there, and let's try moving. Okay, there. I'm trying to center that a little bit better. And let me try bringing it up. There we go. Now, my point being that as you look at this now on the page, for those of you who've been looking at this for help, the page has changed over the weekend. What I tried to do was indicate both the previous week's week at a glance and the current week at a glance. Both of them are up there. And because I think some people weren't noting that the video tutorials are there, I changed the link in that so it's much easier to get to. So for example, if I go to the video tutorials, what you see is a page like this, and if you wanted to see something about a motion problem or a mixture problem, and this was up Sunday morning at about 8 a.m. But if I click there, then I look at what's popped up on the menu. There is a mixture problem, a presentation on that for 6 minutes. And then if I scroll down, there's the motion problem with a presentation at 10 minutes on motion problems. And the idea is that you can go back and look at what we did without looking at a whole lecture. So I've managed to cover all 2 weeks for the links on the video tutorial. So anything that we've covered that you want to go back and review, you should be able to do. Now, if you find that something you wanted, you remember we did, and is not there, let me know. One thing I still have to do, and I haven't decided how I want to link it, are the problems we've talked about. And I need to, I think, make a separate link, just problems, page number, and problem, so you could see a problem and see how it's done. I think that would help. But that's still in the development stage. Now we come back to the page. The simplest way is to back out of a page. And up here at the top, whether you're in IE, Internet Explorer, Netscape, the new Safari by Mac, but the point being you just click back, and if you back your way out, you can get to where we were. Now, I'd like to go to the, let me see if I can get this again. I need to see what I'm doing here. There we go. I'm going to come to the right. This is the previous week at a glance. And I'd like to bring that up for a moment so you can see what's there. This is just the first week, and as we scroll down there, you'll note there are lectures that we did that have been encoded. I'm going to bring that up so you can see it a little bit better. But what you're going to note is that there are photos now that are listed with this, and these are the board presentations. So you can see the pink area. I just checked that before we started class to make sure that it was working. But this is the print version, and if I click on that, what you're going to see is a screen of all the work that was on the boards. I'm going to zoom in there a little bit. Okay, just a moment. Something I didn't need happening, but at any rate, this is an example of what happens. If I click here, what you're going to see is a reversed image of what we had on the board, and you can print these. And this will give you a way of checking your notes. This was dealing with the associative property for addition and multiplication. And as we come down here, you have the identity for addition and multiplication. And I'm going to make that zoom out so you can see the entire page. You can print this without chewing up a lot of printer cartridge or ink cartridge, and it's cost effective and it works very well. Now, by this afternoon, I'm going to be able to upload all of the photos from last week. They were all done. I finished those between 4:30 and 6:30 this morning. And those will be uploaded by, I'm hoping, lunchtime. And then I'm down to 2 days I still have to do in the first week. So I'm getting very close to being, time-wise, on target. Trying to keep to the point where on a daily basis I can put the photos and the links for the tutorials and have those available to you on a daily basis. So that's certainly part of the support mechanism that's being provided. And just for information, as we go back now to this page, there is a link which just says board photos, and if you prefer to see the board photos in the format they were presented, just so that they look like what you remember and don't want to print them, you can see the board photo totally as it was presented for you. And what I've done with the camera, what I do on a daily basis, is try to take these board presentations and simply go ahead and take a photo of them. And part of the difficulty I've had is the amount of time it takes to clean up some of the images. As I was telling Perry, the first 2 days took 2.5 hours just for the photo presentations. I've now managed to get that down to where I can do 2 days in 1 hour. So I'm working at about a little 40% of what it was total. I'm hoping to get my speed at the point where I can do those in about less than a half hour each. But I found out last night at about 10 o'clock when I was trying to do a set that the intensity level is such that I can only go so far, and then I start feeling like a scrambled idiot and look at the page and just nothing's working. So it was 4:30 that I came back to it. Let's see what else we have here. I want to back out of this page where I was, and let's come back to the menu that's here. Just for your information, in case you have forgotten, there is a spring 2003 schedule there, and I want to bring that up for a moment just to remind you as we sit here in this third week, and before we get too comfortable about being in a routine. It's much more comfortable, I think, in about week 3. But as we scroll down there, we note that in week 4, so we're in the third week, that's chapter 2 and chapter 3 we'll be working on this week. But as I bring this across, you saw it, huh? There is exam 1. Okay, just it's after the Super Bowl, so this should be comfortable. Exam 1, January 31st. And what I want to do is click on this link. Okay, so we're going to come right here to this link, and I'm going to click on that, and what you see is an FAQ for the first exam. And what I've tried to do is indicate to you in that FAQ questions about the exam. I'm just going to take this one. How many questions will be on the test? The first midterm will contain approximately 25 questions. And as we come off there, I encourage you to look at it, but I answer questions about how much documentation do I need, what chapters will be covered, how many questions will come from each chapter, and let's see what else is talked about here. What ideas, formulas, concepts will be important to know on the test? How long will I have for the exam, and how should I schedule my time? Will I be able to use notes? Will I be able to use a calculator, and so on? And all those questions are answered for you on that FAQ. So what I am encouraging you to do is get into one of the labs, whether it's the library computer lab, or it's Sierra Hall 221, or Founders Hall 124. You need to at least make an effort to get onto the web page and see what's there, and at least do it once so you get the schedule and know what's happening. And I am aware whether you're doing it or not because I watch the page counts. And if I see no change in the page counts, then I know you're ignoring me, and that's your prerogative. But if you come in and then say, gee, I need help, and I'm not managing to do anything that's making sense, then first thing I'm going to ask you, have you taken time to look at the tutorials? Have you been printing out the page of notes from the board so you can see what's there? What notes have you taken in addition to that? You're going to have to pay some of your dues if you intend to get the support that comes from just dropping by an office. Now, one last thing as we come back to this, and I'll try to get this out of the way. In addition to what's here, of course, is the syllabus, which talks about the grades. And then if you are trying to do this from home, please note there's a simulcast link, the free real video player, and then, as I mentioned to those who are watching in the labs, as part of their course content, there's the email to me, and you just click up here, and this provides the way of sending a message to me and saying you are alive, you do exist, and you're still involved. So that's enough on the video presentations. Any questions there? Okay. So with that, we'll close out the browser and come up with another browser. And one of the things you need to remember is that when you're doing things on the computer and you try to reference something and I say it's been updated and you look at it and it doesn't look like it's updated, it should say the current update. So for example, on the 19th, some of the material was updated. That's the date you should see. If it says 113 or something, then what that means is the page has been temporarily placed in a file so the computer can get to it much more quickly than having to go to the server. So you have to refresh that or sometimes eliminate temporary files on the internet so that you get the current week at a glance. Okay? And I update that. We're into the third week, and I didn't do that yesterday because I had no lecture content on the third week. Once I get lecture content in the third week, I'll make that link the current link. So probably tomorrow morning, the week at a glance will be the third week, and the previous will be the second. But no questions on that, I take. Okay? Then what I'm going to do is close this down so I can get the computer moved out of the way. Another question that was asked while this is happening, are we going to be doing, courtesy of Bill Gates, are we going to be doing Math 90 next semester in a similar way? And the intent at the moment is yes. Now, it's conditioned on one basic requirement from my point of view. There is a concern about the current text they're using for Math 90. And if they plan to change the text one semester later, I will not do Math 90 and then have to completely redo everything next semester. So I'm trying to encourage the committee involved to go ahead and make changes on the text this semester so we would have a text that will be used for 3 years or so, and so that the video presentation doesn't go out of date immediately. So that is my plan. We have not selected classes for next semester, but I think that there's certainly evidence right now that even though you don't participate in the process, many other people are doing. In fact, 3 times as many people as are in here may be involved watching the video presentation, and their feedback has been very good. And one of the things they comment on is how well you select questions in here. They say, gee, those were the same questions I had, and therefore they don't feel like by not being here that they are in some way losing an opportunity to participate. And of course, one of the things I've said, and I guess it merits saying again, and that is one of the opportunities that you have if you're watching this semester. It won't be there next semester, but one of those options is to call on the phone, and I check my voicemail at 6:30, I check my email at 5:30 a.m., and then if there are requests, I try to go ahead and reflect those questions in my presentations of what I do on the board. So we'll be going to there in just a moment. On the homework I just returned to you, the questions were done very well, and I was very pleased overall with what was there. The way the scale goes this time, you were allowed 1 mistake and still get a 2. If you had 2 major mistakes, then that was a 1.5. 3 or more major mistakes went down to 1 unless you really didn't do what you should, and then it went down to a half out of 2. But for the most part, the concern was leaving a problem blank. And if you left a problem blank, that did not set well with me. And leaving problems blank will pull your grade down from a 2 to a 1.5 very fast. The check marks, I think you've probably figured out a check mark is good. It's not wrong. It means I checked it off. It's good. When I have an X, that's not good, and then I usually write something or throw blobs of ink on your paper and that kind of thing. But the comments, I try to write if there's something that I see as a problem. One of the things some of you will find is a comment, where's your diagram? If a diagram is included in the problem, I'd like to see it as part of the problem. And if you were showing that a proportion was equal, then I wanted to see the work in that, showing me the cross product. Now that brings up a question that was addressed this morning or yesterday on an email. It's number 17, page 131. It's not today's work, but let's go to the board on that. It's number 17, page 131. And on this problem, I managed to get tripped up, I think, in the same way the person asking about the problem got tripped up. The problem evidently should be written like this, and the question is this equal to 1/10? Now, if you don't see the 1 up here, and you're just focusing on the fraction, when I was looking at the problem when Pam had her book open, all I saw was the 2/5. But the 1/2 is in the numerator. So if you check the cross product, and the argument is this is a true statement, then your cross product is 1/2 times 10, which is 5, and then 5 times 1 is 5. So the two cross products come out the same number, so this proportion is true. So we would say then a true proportion. Okay. Again, where I think the problem occurred, you saw 2/5. Now, if all you see is 2/5, and you have 2/5 equals 1/10, clearly they are not the same, and the cross products will not be equal to each other. So hopefully that answers one of the questions that I was asked to respond to. And now I have a mess up here. So just a moment. Let me see what I can do to get some space here. And put a book up here in a moment. The questions are on the word problems, of course, and I have a list of questions that have been requested, and the list goes more perhaps than the amount of time I have to cover all of them. But let's see. Page number for the work today is about 148, 149, in that range. And let me check the list I wrote down. I'm trying to do this in a little more organized fashion. I'm writing them in my date planner. But it's 21, 25, and 37 in that group. So 21. Okay, these are mixture problems, I believe. Let's see what we can do here. Now, why? something. There we go. Now, does that look pretty good? I think it does, Debbie. Let's try that. We have a certain metal, and it's 20% tin. Now, how many kilograms of this metal must be mixed with 80 kilograms of a metal that is 70% tin to get a metal that is 50% tin? Now, this has been set up for you to help you in the process by identifying what you're going to use for X. You didn't have to do it this way, but you could have used Y, you could have done something else, and you certainly don't need a table. But if you're going to use the approach that's suggested here, if X is the amount that is going to be for 20%, what are you going to indicate for the number that goes with the 70%? Well, you're going to have an 80 there, correct? Mm-hmm. Right. And then the mixture is going to be X plus 80 down here. And then the idea is if you take these products, remember there's decimal points involved, then you're going to get the amount of pure tin in each of the two subcategories, and that must be the amount of tin that is in the total. So as we come off there for a moment, the first thing I expect to see in number 21, and this is on what page that would help? 145? Thank you. By the way, note that's a Fibonacci type number. 145. 1 and 4 is 5. Okay. I want you to tell me what X is. Well, in this case, we're letting X be the amount of what? Of 20% tin. Now, I'm going to put 20% tin. And then, at that point, depending on whether or not you want to run a table, and there is not a need to write out the table each time. That is something that benefits you. But my argument is that I have then at 20% 0.20 X as the amount of tin in that part. And I'm combining that with 80 kilograms of 70%, and I'm arguing that the amount of tin in those two pieces or parts put together is going to be the amount of tin in the total. So I know I have a 70, or what is it, a 50% mixture at the end. And how much material now do I have combined? Well, it's X plus the 80, and that becomes your equation. Thank you. I left the 0 out. Okay, thank you. Yes, it should be 80. So 0.20x plus 0.7080 equals 0.50 times x plus 80, and that what might be a very nice first step.
Get rid of the decimals.
Multiply everything by 100. Now, in this case, you could have argued 0.2x plus 0.7 times 80 equals 0.5 times x plus 80. I would much prefer when you convert from a percent to a decimal that you use both digits. I think it's just a good habit to get into, and you tend not to get messed up. Now, from here, the phrase I would like to use is let the good times roll. Because if you get your equation right and you now have practiced doing equations, the next part is a slam dunk. You're there. You get X and you answer the question in the problem. Do we need to go further? In the sake of time, I'd like to look at setups more than I would just what you do beyond this point. But if there's no question there, then the next one in my list was, I believe, 25. Now, 25, let's see if I can get the, that's about as good, I think, as I can do, Debbie. And I'm not sure how to pronounce this. Minoxidil, thank you. Okay, is a drug that has recently proven to be effective in baldness, and a pharmacist wishes to mix a solution. So if we come off there for a moment, the model I have in the problem we just did is the model I use for all mixture problems. They are all going to be done basically the same way. So I have to ask, how much am I combining? Now I want a solution that is 2%, and I'm combining what? A 1 and 4%. Now let's try zooming in, or just that much, because with what you can see in the board, you can see that I want to take 1 and 4 and get 2. So if I look at the problem, and I'm going to try setting it up right below the other one, I first have to identify what x is going to be, and I'm going to mix some 4%. Is that right? So let x be the amount at 4%. Now, I'm not going to try to write in minoxidil in terms of what I have here, but just let x be the amount of 4%. Now, I have 1% and 4% that's going to give me 2%, correct? So I have a 0.1 something, 10, times something, plus, so I'm just going to leave a little space here, plus, and I didn't do that well. I was thinking of 1% and wrote 10. I want 1%, so how about 0.01 and space, then plus 4%, which is 0.04 times space, and that's to equal a 2% solution, 0.02 times space. Now, that is the model. I have to put in some pieces here that are missing. Now, the question, I had a certain amount of 1%, correct? How much 1% did we start on? 50? 50?
Yes.
So 50 milliliters. So where I have this first wavy line, I'm going to replace, well, let me leave that wavy line there and just come down here and show you the process, because I'm going to put that 50 here. So I'm filling in a blank. The model is structured in the percentages that are involved. Now, I don't know how much for x, so I'm just going to plug that in. And the 0.02, I have to look at the total amount that I have together, and that's going to be the x plus 50. And my argument is what you did in the first is mirrored exactly in the second. The only difference is the percents change and the substance. But that's the template, the boilerplate. Once you see this structure right here, that's the key. Now, I don't want to set up all of them, but I want to set up some of them so that you can see what's involved. I'm now going to go to the next set. The next set of problems that I had requests on were 23, 35, and 53. So the request on number 35 is a problem that involves, uh-oh, okay, I just heard something snap out, and I think maybe a plug. Hold on, Debbie, just stay where you are. I'm just going to look and see if a plug came out. Nope, we're okay. That means the computer is charged up. I can get rid of that line now and move this out of the way. Okay. 35. Now, a cashier has a total of 126 bills made up of 5s and 10s, and the total is $840. Okay? Now, I need to know something more. Let's see, the total value of the money. Nope, that's it. Okay, I thought I might have something about, did I have more 10s than 5s or whatever. The key here is I have 126 bills. Now, in word problems, a very important kind of, let's see, what do I want, tip, observation. If you know two things are going to be 126 when you add them together, if you know one, like one is x, the other has to be 126 minus x, the difference. Again, you have A and B add together to give 126. So if I know this one is A, then the other one has to be 126 minus A. It's what's left. Well, that's the key to this problem. Now, I assume that I'm asked how many of each kind that I have. So the problem is number 35, and so we'll come over to number 35. And so the idea is that the total is 126 for the number of bills, and I don't know which makes more sense, but I'll just say let x be the number of $5 bills. Now, the one thing I'll be critical about as I look at your results, x is not $5. If you say let x equal $5, you've told me what x is. X is no longer a variable. You've given me the value. If you say let x be the number of $5 bills, that's what I don't know at this point, and that's what I'm going to use. Now, it might be worthwhile to then say 126 minus x equals the number of $10 bills. But once I'm there, then this style of solution is fairly straightforward. And that style of solution says that the amount of money you have total, and I think that's $840, must be equivalent to how much you had when you combined all the bills. So if I had X $5 bills, how much money do I have with the X $5 bills? 5X. And then, how much money do I have for the remaining $10 bills? Well, however many that is, I multiply that by 10, and I now have, my total is $840. Again, the particular problem is not as important as the template for the solution. Whether we're talking about tickets that are sold for a concert, or we're talking about the money that a bank teller has in a drawer, the key is still the same. And do you see the great similarity between a mixture problem and a money problem? Because they are set up on the same premise. But you have to ask, what are you trying to show is equal? In this case, your total money for each of the two denominations of bills must be the $840. If you have trouble with a problem like this, ask yourself, what would happen if I had 30 $5 bills? How many would I have then for the $10 bills? Well, I'd have to subtract 30 from 126 and get 96. Then I would multiply 10 times 96 to get $960. I'd take 5 times 30 to get $150. Think your way through the problem with real numbers and ask yourself, does the logic make sense? And then try to translate that into an algebraic structure where you let a symbol represent what you're trying to find. Now, when I solve this problem for x, you are going to have to tell me the answer to the question, which is how many $5 bills did I have? How many $10 bills do I have? As I look at your presentations, I will be looking for the completion of the problem. Did you do what you were supposed to do as you finished it out? Is there any question about this one? Now, my guess is, if you had trouble with some of these problems, and you look at the problem now that it's presented, it doesn't seem nearly as bad as it did while you were struggling with it. That's clear. That the clarity now when somebody says, gee, this is the way you could have approached it, it doesn't solve the problem you faced over the weekend where you struggled with the problem and said, what am I supposed to do with this type of problem? The issue here is not to see every problem as something totally different. Again, you catalog and you say, what kind of problem am I doing? How did I solve a problem like that before? If it is a mixture problem, what am I looking for in the solution? And that is looking for patterns, not how everything's different. You're looking for a similarity, a template, a boilerplate that you can follow once you know the type of problem that will help you solve it. So we have time to look at another one. I believe 55 was the next one in my list, but let me check. I'm 53. Sorry. I'm 53. Now I'm hoping that's a motion problem. Let's see if I'm disappointed, because I wanted to make sure I tried to give time for each. Okay, this is number 53. At a given hour, 2 steamboats leave. Well, one of the obvious things as we come off there, this is sort of out of modern society. Steamboat. You may have no idea. Just think of it as some kind of conveyance that you can do on water. And whether it's powered by steam, diesel is immaterial. Now, they're going in the same direction. So let me scroll across here on a straight canal. Okay, let's come off there for a moment, Debbie. Don't want to get people dizzy as I try scrolling back and forth. here's some important information. One of them travels at 18 miles per hour. Now, you'd think they'd tell you knots or something instead of miles per hour, and the other travels at 25 miles per hour. So now you know how fast they're going, and you want to know in how many hours will the boats be 35 miles apart. We're going to draw boats. Well, we're going to draw a diagram. My boats aren't going to have paddle wheelers on them and so on, but we're going to try to draw a diagram in which I'd like to illustrate what's involved here. But the key is you need to know a formula for distance. And that formula is D equals RT, the dirt formula. You need to know that formula in order to do this problem. And the diagram is everything here, to know whether you're subtracting or adding distances. Now remember, when the two planes were taking off in opposite directions at the same time, we added the distances to get the total. The same when you have two planes flying toward each other. But here we have going in the same direction, and we're interested at some point in time, if one goes faster than the other, you're going to be a certain distance apart. Now again, what I've tried to illustrate there is the need to verbalize the structure of the problem. So Debbie, in the space we have behind me, I'm going to go ahead and try, this is number 53, correct? Which, by the way, is the reversal of the digits 35. But that doesn't make them come out the same. But if they did, we would consider the number palindromic. So I just want you to realize that if you have 1, 2, 1, it would be palindromic because you can read the number backwards the same way it does forwards. And so what, I know. Okay, so we have the pier. And we are taking one boat going this direction, the other boat's going this direction. And at some time, what's the distance here going to be? 35 miles apart between the location here and the location here. That's what you're looking for. I think it makes sense to put the faster speed down here. So we have one boat doing 18 miles per hour and the other doing what? 25. So this is the one that's going faster. And I haven't selected a variable, but the variable I'm going to say is let t, and that doesn't look good at all. Let's try cleaning that up. Let t equal the amount of time involved. I'm just going to put amount of time. T is not equal to time. I'm saying the amount of time. Now, in this case, you could get by with it because we measure time as a number. But I'd like the amount of time involved. So how would I set up the equation? Well, I want the larger distance minus the smaller distance to be what? 35. So if 25t is the longer distance, the shorter distance is 18t. Now, once you have the diagram, and I guess I could put some kind of dotted line here and some kind of dotted line here, and saying that the distance between those is the 35 miles. But 25t minus 18t is equal to 35, and I'm done, and the rest is solved. Now again, retrospect, somebody else doing the problem for you. If you had trouble with this, it's going to look like, yeah, can do that. What do you need to do? First, I'm collecting your homework tonight, or today, from last night, and I would like you, if you have difficulty with one of the problems without your homework in front of you, go back and try doing that same problem, trying to remember what was done in the board presentation without referring to notes, and make sure you can set it up. Then, maybe try a problem very similar to it that's odd numbered that you could check as a solution and see if you have success. But the key to all these problems, don't look like every new problem is something like you've never seen before. What you're trying to do is find a pattern, how you can, once you identify the problem as a particular classification, motion, mixture, integers, and there are other type problems we're going to do, but once you've identified them, you have an idea of what to do. That takes you out of that kind of reaction, I don't have an idea in the world what to do and I'm lost. That's what you're trying to avoid. Now, that doesn't get all the problems. I've done 4 of the group. I felt I needed to leave some time for me to cover new material. So with that, will you please turn in your homework, pass it over to Vandy over here in where I am on this side of the room, and he will be more than willing to return the papers to me. So as I come back off there, we have a new section that should first remind you of something we've already done, but before I get to there, let's make sure the papers are up. Everybody have their papers turned in now? Please get it up near the front, please. And we'll go from there. Okay. Operate quickly here. Pass it down. Okay, Perry, one more coming behind you. Okay, thank you. More coming. Okay, this is like more coming. Now, that's all the papers, and that anything following this would be not accepted because those are the papers done now. Anybody still have the paper that has not been turned in?
I have not. A couple of them I didn't understand that you explained that I want to work on more.
Give you just a few minutes to do that quickly, and then they need to be turned in. Okay?
Okay.
So I'd like to have you turn to page 149. And Debbie, if you'll do the document cam. What about this looks familiar? The big print in red. Okay, the addition and multiplication, yeah, that's but the properties. What could you eliminate from this and say, oh, we've done that before. Instead of inequality, the addition and multiplication properties of equality. So we're going to do exactly what we did before with inequality rather than equality. And you may ask, is there a difference? Part of that answer is no, part of it is yes. So let's first remember what we did with equality. So I've got this space, Debbie, behind me. I think that'll be adequate for what I want to do. And we're going to come over here and say, what was the statement for equality? If A equaled B, what did we argue for equality with addition? What was an implication? That A plus, now notice, I'm doing an arrow, an implication. That A plus C was what?
Equals B plus
Equal to B plus C. That is, we added the same thing to both sides. We still had something that was equal. And we argued that the solution to an equation is not changed if you add the same number to both sides. And it didn't have to be positive. It could be a negative. What about inequality? Well, if A is less than B, then the implication is that A plus C will still what? Be equal to, or less than, I'm sorry, B plus C. That works the same way. Greater than works the same way. So what could I have in addition to the less than symbol? The greater than symbol, the less than or equal symbol, the greater than or equal symbol. So this is just a generic inequality for the moment. I'm rather curious. Let's look at the document cam for a moment. Here are the symbols that we can have, so you can trade in any one of those symbols at the bottom of the page for what's there. So let me come off that for just a moment. I'm curious how, okay, I stumbled into an appropriate presentation for what the text does. Let's look at that. Here's exactly the same statement. If A is less than B, then A plus C is less than B plus C, and you can replace what you want with the less than here. You have a choice of 4. Well, what about this one? A equaled B implied what? That if C was non-zero, now this is the caveat, C has to be non-zero, but we said that A times C is equal to B times C. We could multiply both sides by the same number, not 0, and still have equality. Now in this problem, note, C can be a fraction. We have to be careful that when we think number, we don't what? Limit our thinking to counting numbers. It can be a fraction. It can also be negative. But there's the rub. Okay, so here we say C not equal to 0. That's a limitation on that one. It is not a limitation on the first 2 lines I have. Okay? Now, this is where we have inequality, and I'm going to make the statement C greater than 0. A is less than B, C is greater than 0. If you make that limitation, what can you say? AC will be less than BC. But that only works if what? C is positive. That's where we have to be careful. Now the question, of course, what happens? And Debbie, what I'm going to have to do, we're going to come back to the book for a moment, so let's come back to document cam, and then I'll be ultimately going over to the other side because I'd like to look at what we're doing there. But remember, this was the first statement for the addition property, and we're going to come off there for a moment, and I'm going to go to the multiplication property. And I'm not quite sure the form it's been stated. It's in two forms. Okay, here's the first one. If A is less than B, and of course there is the restriction that C is positive, then AC is less than BC. But notice the second line, I'll scroll that up a little bit. You don't see the restriction on the second group in blue, but that's when what? C is negative. So when C is negative, the inequality does what? Reverses or switches itself. Now, I don't know what kind of language you're familiar with there. The text is saying it reverses the direction of the inequality symbol. Switch, reverse, more or less implied. So if I'm going to do what I have in the board, I would need two statements. I have the one that's up there plus the second one again that is, and I just, let's see if I can get that high enough on the, there we go. And let's get it in focus. It just doesn't do very well. This use of color in the text is great until you try to get it on a document cam. If C is negative, it switches the inequality. So the question, of course, how does this work on a problem? And Debbie, what I'm going to have to do, I guess I better have you come back with camera 2 momentarily. Let me finish the statement in the front board, because what I have there, okay, I'm not sure which way you're going. Okay, let's see where we're headed. Okay, thank you. Now, this is a case where A less than B with C what? Less than 0, meaning negative. And if I do that, then this implies that A, C will now be greater than BC. And that's what we mean by reversing the inequality. We go from a less than to a greater than. And most of it is just be careful of what you're doing. Now, what kind of problems do we do with this? So what I am going to do, I'm going to walk away from there for a moment, and I'm going to look at a problem that's involved here, because the problems are pretty straightforward, but you just have to be cautious. Now the first one, let's look at this. I have 3r less than negative 18. The key, you want r by itself, correct? So you divided both sides by 3. And nothing changes in the inequality. You still have in the inequality a less than symbol. The negative on the right side did not affect this. Okay? Now, in terms of solutions, please note, we've talked about this before, and let's come off there for a moment, Debbie. I'm having trouble getting the camera to not create keystoning on me. Let's see if I can get that. There we go. Here's the type of solution, 3 different ways. R less than negative 6, minus infinity to negative 6. That's this, what appears to be an ordered pair, but that's saying the same thing, and then what on the number line? Now, what's done here, I did a circle rather than this open parentheses. I prefer circles there, open circles versus closed circles. So I would just place an open circle there, and then note, I'll have to slide this just a little bit. Thank you, Debbie. The arrow goes to the left. Okay, so let's come off there for a moment. Now, let's see what the effect is on a negative, and this is what I want to talk about. Okay, let's come back to here. Now notice this time the negative is in front of what? The variable. But what do I want? The t by itself, so is it clear why you're dividing by the negative 4 on both sides? Now, here's where you have to be cautious. This is a real subtle issue. Note at the top it was greater than or equal. Here, once you've divided, what must you do? Change the inequality in the story. You cannot leave that greater than symbol here with this problem. Now this is where I'm going to go to the side. Let's leave that up on the board, Debbie, because I want to give you an out here. This isn't going to get you off the hook totally, but there is a place where if you note you're making errors and you want to get out of the dilemma. Oh, curl plus 8. Okay. Now, didn't need the plus sign, but it's easier than erasing. I have a negative 4 that I need to get rid of. What we just talked about, you can't now just throw a negative 4 underneath here. That's what you're going to be tempted to do. You do that and you're making life very dangerous for yourself. Rewrite the problem with the negative 4 shown and then do what? Reverse the inequality symbol once you have done that. But you cannot just put the negative 4 up here and divide. You do that, and I will take credit off. Now, at this point, this is t. That becomes less than or equal. This is a quotient of a positive and a negative number, and that will come out t less than or equal to negative 2. And then, of course, what you're asked to do, and I want you to do this in two forms, negative infinity to negative 2, and this should be what this time? Including the negative 2, so what should I do instead of the parentheses? The little square bracket. And, well, equality includes the negative 2. It would make it a true statement. And then on a number line with 0 here, and I have a negative 2 down here, I would take the 2, fill in the space, and have an arrow to the left. And that would be my solution on a number line. And I want both of those done. Now, my comment, how do I avoid the trap that I may get into? Here's a choice. Rewrite the original inequality. Add 4t to both sides. Add 4t to both sides, and I get 0 is greater than or equal to 4t plus 8, correct? Then subtract 8 from both sides, and I get negative 8 greater than or equal to 4t. Now, I don't want the 4 there, correct? And it's positive, so this time I can do what? Immediately divide by 4 because it's positive and I don't need a new line. This is negative 2 greater than or equal to t. Now you have to know what to do with that. To say that negative 2 is to the right of t is to say that t is to the left of negative 2. You have to be able to make that transition. But notice by making sure I rewrite my inequality so I have a positive coefficient of the variable, I can avoid the trap. Your choice. Just don't get trapped. Okay. Any questions there? Most of this, comparatively speaking, is a matter of what we did with equations. You aren't dealing with the word problems in the same way. There's a nice 3 steps involved here. If you look at page 154, looks just like the process we did with equations, so I don't think we need to belabor that. That's on the top of page 154. Simplify each side, isolate the variable, and get the variable by itself. You isolate the terms and then the variable itself. So let's see what you can do to enjoy. There is a little bit of language here, and I just bring this up. This becomes, in the stat course, a tremendous area of difficulty. What does it mean to be at least? And that means greater than or equal to, and the phrase at most, this is on page 156, at most means less than or equal to. Those two phrases must be translated correctly when we are talking about translation problems. And in the stat course, when I use the phrase at least, we talk about quality control. Having at least one defective means x is greater than or equal to 1. And that seems to be a problem with language and translation that is quite difficult for students in the stat area because of their algebra background or lack thereof. There are 70 problems on pages 158 and 159. So pages 158 and 159, Debbie, I think I'll just go over to the sideboard. So if you want to, just with what we had there on the side for the moment, and I'll just walk over there. So this is page 158, 159, correct? So let me just place that here. So homework. 158 and 159, 1 through 70, the set of x such that x is equal to 2n minus 1, and it's understood that n is an integer. What did I just tell you? The odd number problems. This is the set of odd number problems where n belongs to the positive integers. And I'll start giving your homework that way. Translate this phrase for the moment into odds. Have a great day.